All right, so this video is continuing the Ecolicious report, and we want to move on to part 5. So we want to know, do your results or does my results answer the scientific problem? So I need to go look at my scientific problem and I need to figure out, well, now that I know my problem, what does the data say about it? Did I learn anything that might help me better understand my scientific problem? So first, let's go look at the problem. It says, how do humans impact our environment? So how do humans impact our environment? So that's our problem. How are we impacting the environment? And so the question is, do our results tell us anything about how humans impact the environment? That's what we need to decide. So let's first look at our graph that we created. And let's say that the graph, let's say our independent variable was, as we discussed before, it's the brown water. And that's sewage water, or sewage treatment H2O. And that was our independent variable. So our independent variable was sewage treatment. And we want to study, is there an effect of sewage treatment on how plants grow in the environment? So the first thing we need to do is look at either the graph that we created, and we need to look at it. So we have different cups with brown water in them. Eco cup number 1 is the gray lines. That was one of our experimental cups. You can see that all cups on day 1 and 2 are pretty similar. So Eco cups 1 and 2 got the independent variable. They got they're our experimental cups, and they got the brown water in this example. And you can see that on the first 2 days, they pretty much had the same level of growth. Our control received normal water. So the control received the normal type water, nothing special. The control cup here, number 3, they didn't get any brown water at all, right? They just got typical water and grew normally. If we go on to day 3, Eco cups 1 and 2 and 3 are closely growing similarly. So the plants that are growing in there, their plant heights, right? The plant heights on day 3 are pretty similar. As we move on to around day 4, in this example, we have Eco cup 1. The plants didn't get very tall. They're getting the brown water. Eco cup 2 got a different amount of brown water, and you can see their plants are much taller. And then the control cup is kind of halfway in between. Their plants are taller than the plants in Eco cup 1, but they're not as tall as the plants in Eco cup 3. After day 4, we have, for whatever reason, we got average height the same on day 5, and then day 6 again. Each cup, even though some cups got the independent variable, the brown water, and some didn't, they're still kind of in the same zone. There doesn't seem to be much difference in the plant growth here. On day 8, our final day of measurements, we see the Eco cup 1 that received the experimental treatment, the brown water, and we see the Eco cup 3 that didn't receive any, pretty much grew the same. And then our Eco cup 2 grew a little taller. It was around, on average, the plants in there were about 30 centimeters tall. So looking at this, we have to look at how similar the data is. Is the data similar enough that we can say that the independent variable didn't make any difference? Or can we say that the results are different enough for you to feel like, yeah, the independent variable did have an impact on the plants. Brown water does cause the plants to respond. Another way we can look at this is not just the graph, but your data. And this is just a data sheet I created. We have days and then how tall the Eco cups were. And you decide, how many days here, days 1 through 3, I'm going to highlight them. We also have days 5. We have days 6 and 7. And then we have these cups here. All yellow zones mean they pretty much grew the same. You can see that there's more days that they grew the same, regardless of what cup they were in, regardless if Eco cup 1 and 2 got the brown water. There's more days where they're pretty much the same level of growth. And when we put that into the graph form, it looks like this. This tells us the same information in graph. So I'm wondering, was there really an effect? Is the effect different or not? I think for me deciding, just based on this graph and seeing how many numbers are similar, the fact that plants generally are growing the same in each cup, it's not exactly the same, but they're pretty close. Based on this, I'd feel like maybe brown water doesn't have an impact on the environment. Maybe brown water doesn't really have an effect on the plants. And if it does have an effect, like here, this box does stand out. EcoCup 2 does have plants that are taller, but is it a big difference? Is it a big enough difference for us to worry about the impact of brown water on the environment? I'm going to write what I think based on what I've seen here. How similar the data is, I'm going to say that there's not a strong impact. And based on how close we can see in the graph, they grew pretty similarly. I'm going to argue that the problem, which was, let's look at the original problem. The original problem asked, how do humans impact our environment? Well, let's talk about it. So I'm going to write my response. So do our results answer our scientific problem? I'm going to say the results recognize humans create brown water. We create sewage water. When the brown water, and this is our independent variable, I'm going to put IV for short just to save time. When the brown water was applied to cups 1 and 2, the plants didn't grow much differently than the cups, than cup number 3, which had a normal environment. It was our control cup, right? Notice I'm using these important words to clarify. So these words help with language. All right. Because the brown water, and that's our independent variable, didn't strongly affect plant growth, I'm comfortable arguing that brown water is not a negative or positive impact on local organisms in Burbank environment. So the plants pretty much grew the same regardless of what cup they were in. So I'm going to suggest that the plants really didn't get hurt or helped by the brown water because they pretty much grew the same. So to go back to the problem, our scientific problem was, how do humans impact our environment? Well, although brown water is released or used in our city, the water doesn't appear to have a strong effect on local plants. So that's the impact. So although we know that there's brown water in our environment, if I just go by the data table and how similar the results were, and if I look at the graph and see how similarly they grew pretty closely. There wasn't much difference. I would say that my argument is that there isn't a strong effect. Notice I'm saying strong. So there's pretty much a strong, it doesn't appear to be a strong effect on the plants. There may be a small effect on plants, but this would need to be investigated later. Or tried again. So you can see it's quite a bit of response. This is a paragraph response using evidence. I'm saying, yeah, the environment is impacted by brown water, but because the plants grew similarly, in the different eco-cups, we have eco-cup 1 and 2 grew pretty much similar to the cup that didn't get the brown water sewage treatment water. So I'm arguing that, yeah, the brown water is here, but it doesn't have a strong effect. I'm identifying which things are the independent variable. I'm talking about cause and effect. I'm saying that I'm arguing that there wasn't a negative or a positive effect on the brown water, on the plants. So I'm saying, yeah, maybe we don't have to worry about the human impact of brown water in Burbank because it doesn't seem to be very strong. All right, hopefully that helped you with completing question 5. All right, go and use this as an example as you respond to the question yourself. And remember, step 5 here gives help and clarifications. And that's page 3 here and step 5. So these are the questions we need to ask ourselves as we complete this question. So you can go with the script or you can look at these questions and then how would you answer them based on the data you get from the graph and the table. Good luck.